Hi, Ahava. This is chapter 11. Um, and we're going to try to do this all through highlight videos with a small twist. Some of the videos are going to require you to have your notebook around. This one is not one of those. This one you're just highlighting, and then after that you get to go do homework. Isn't that nice? No, nothing to figure out because I'm pretty sure you already know this stuff. Today, these are the materials that I plan on using. We got a yellow highlighter, a blue highlighter, and a pen if I need it. I don't know that I will. Remember, you're highlighting directly in your book, so there shouldn't be any stress there. Okay, so 11.1 is all about areas of squares and rectangles, and there are some things that it's interesting for you to know, and there are just some things that you have to have memorized. So if I put it in blue, remember that it's just interesting for you to know. And if I put it in yellow, that's something you need to make sure that you already have memorized or that you're going to memorize. Once again, make sure all the yellow stuff gets on that page of yours for your definitions. Okay, so 11.1, interesting things for you to know. They have something called the area postulate, which basically says that every single polygon that there is has an area within it. That's about it. There's the area congruence postulate that says if two polygons are congruent, then the areas in them have to be the same. Kind of self-explanatory. And then there is the area addition postulate, which says that you can add areas to find the area of an overall figure. Or you can split a figure up into two separate figures to find the area of the overall figure by adding those two separate areas together. Which all brings us to the important piece of information, which is the formula for the area of a square. I don't care if you know the words or not, you got to know the formula. That's about it on page 440, which leads us to the next page. Look, it's upside down. You know, I will conquer this one day. I promise you I will. So they talk about square units at the top of this page. So it's kind of important that you understand a square unit just is one unit on each side, and it forms a square. If you want to know how many square units are in something, then you have to add up how many little squares you have. That gets a little more tricky when the little squares aren't all squares because you end up with some funky shapes. So that being said, you're going to have to know things like the formula for finding the area of a parallelogram requires the identification of the base and altitude. Any side can be considered the base of a figure, and its length is denoted by B, and altitude is a segment perpendicular to the base, and joining the base to the opposite side. The length of the altitude is called the height. Those are all very important things. Whenever we talk about height, it's always at a perpendicular. If it's not at a perpendicular, you can't really call it a height. Same thing for an altitude. The height represents the length of the altitude. Same thing here. You can have your base on top or you can have your base on the bottom. It does not matter. Here you can have your base on the bottom or your base on the top. Even if your base is on the bottom and you're finding the height on this side, it doesn't have to be inside the figure for that to happen. It just has to have a right angle where they join. Which leads us to the area of a parallelogram, which is area equals base times height. Most of these I think you already know. They have some examples down here. Like I said, most of these I think you already know, so I'm not too concerned about those. And then these are the classwork exercises, the practice exercises, and then you have area of a parallelogram in section 11.2. I know we're flying through this stuff, aren't we? Because I know you already know it. You've seen it before, so I'm not too concerned about it. In this one, we have the area of a parallelogram equals the product of the length and the base of its corresponding height, which we just talked about. Oh, I'm sorry, the other one was a rectangle. This one is a parallelogram. Length times width, base times height. They called the other one base times height, didn't they? Hold on, gotta go back and look now. I wasn't looking very carefully. Woohoo! Yes, they did. That's because they are at a right angle. That's why they called it a base times a height. Most people call it length times width. Either one is fine because they're talking about the same thing in a rectangle. In a parallelogram, the base and the height are not the sides. So you can't say length and width here. They also talk about in this section a few other things. So up here they have the theorem for the area of a triangle is 1/2 base times height, which I know you've seen before as well. The area of a rhombus equals half the product of the diameters. The area of an equilateral triangle equals 1/4 the product of the square of the length of the side. And they have the little explanation over here. This is not something you need to have memorized. Eventually, I just expect you to find it the old-fashioned way. So there's that. Those are all the things I needed to remind you of. Oh my gosh, I could probably go on and teach another 2 sections, but that would give you way too much homework for one particular night. So let's talk about the homework. I wanted to find a slightly clearer spot so that I could write it down, but it's not as easy as I thought it was going to be to find that here. So I'm going to try writing it down here if I have enough room. The classwork, because we're talking about 2 different sections, you have 2 different pages. On page 443, you have numbers 3, 7, 11, 15, and 21. And then on page 447, you have numbers 3, 9, 13, 17, and 19. And then the homework on page 443. Whoops, I gotta hurry now for real. Homework is numbers 5, 9, 13, 17, 23, and on page 447, numbers 5, 11, 15, 21, and 23. Don't be shocked. A lot of these are really easy and simple, but some of them require that you use stuff you've learned in the past so that you could find the information that you need to know. So I hope you remember all of chapter 8 because it'll be important. Okay, bye. I'll see you next time.